Hello and welcome to the D3.js course. This is the most comprehensive course on D3 around. By the end of this course, you will have a solid understanding of D3 and its features. D3 is a JavaScript library that comes with dozens of features for creating data visualizations. Here is what you can expect to learn throughout this course. Currently, you're in Section 1. This section will go over some of the concepts you'll need to know throughout this course. I go over what data visualization is, why you should use D3, and we set up a server to get started. I want to make one thing clear. This course is not about design or data science. The core focus of this course is D3 and the code behind D3. Data science and design principles are topics that deserve a course of their own. In this course, we mainly focus on the code and why you write things a certain way. This section will only give you a brief overview of things related to design and data science. With that being said, you are expected to know the basics of HTML, CSS, and JavaScript. In Section 2, I provide a primer on two topics. I go over some JavaScript concepts that you should already know. You can consider this a refresher. I just want to make sure we're all on the same page. The other topic is SVG. D3 is primarily used with SVG. It's important to understand what SVG is and how to use it. If you don't have any experience with SVG, then that's perfectly fine. You will learn all the basics in this section. Then, in Section 3, we'll go over the basics of D3. We won't be creating any visuals or doing anything difficult. This section focuses solely on the code itself and what's happening behind the scenes. Afterwards, in Section 4, we begin actually using D3 to draw charts. For this section, we focus on two examples to better explain and reinforce what you learn. You will learn how to create scatterplots and bar graphs. More importantly, you will learn about scales and how they can help us size our charts appropriately. In Section 5, we'll continue working with the scatterplot and bar graph. We'll refine how it looks and begin adding interactivity. This includes learning how to add, change, and remove data. We'll learn about transitions and animations. You'll also learn how to create your own custom tooltips. In Section 6, we begin stepping away from the charts we've created so far and start exploring other types of charts. You'll learn how to use layouts and how they can help us build some of the most common types of charts out there. In Section 7, we'll start talking about how you would go about creating maps. We won't just draw maps. We'll also learn how to add interactivity, such as panning and zooming. By the end of this section, you'll be more than comfortable drawing maps and understanding the fundamental concepts of GeoJSON. Lastly, in Section 8, I go over some topics I may have missed, such as responsive design. In this day and age, it's important that your charts are responsive for any device. There's a lot of information to go over, and so you will definitely be kept busy. Let's talk about the requirements now. This course assumes you have knowledge of HTML and CSS. We won't use HTML and CSS too often. D3 is primarily JavaScript, and you can manipulate the document with it. Be sure you're confident in your HTML and CSS skills. Along with HTML and CSS, you will also need to know JavaScript. I'll be sure to explain some of the more advanced concepts, but you should have a good understanding of the basics. This includes variables, functions, conditional statements, arrays, and objects. And lastly, you'll need a server and an editor of your choice. If you don't have either of those, then don't worry. In the next lecture, I'll show you how to set up a server for development and suggest an editor. You can use any editor you like as long as it supports HTML, CSS, and JavaScript. At the end of each section is a quiz. Be sure to take it to test your knowledge. When you're ready, move on to the next lecture. I'll see you there. To start things off, I want to start talking about the text editor we'll be using for this course. You're free to use any text editor you like as long as it supports HTML, CSS, and JavaScript. All three of these technologies play a major role in the D3 library, so your editor will need to support them. Usually the editor I recommend for web development is WebStorm by JetBrains. There's a specific reason why I recommend this editor. This is a premium editor, and if you can't afford it, then I provide an alternative at the end of this lecture. For now, let me show you why it's so useful. In the resource section of this lecture, I provide a zip file that contains a simple HTML file. I want you to unzip this file anywhere in your system. Once you have it unzipped, I want you to open it up in your browser. You'll see that it's just a regular HTML document with the text saying, hello. If you right-click anywhere on the page and select View Page Source, then you'll see a new tab open up with the original source code. As I stated earlier, you should have good knowledge of HTML and CSS, so you should be able to understand what this code does. There's nothing groundbreaking about this code. If you take a look at the URL bar, you'll see the full system path. For HTML and CSS, opening up a file like this is just fine. However, later in this course, your code will not work by simply opening up the files in the browser. This is because we'll be learning how to load data through external sources. For security reasons, most browsers will not allow this unless you're on a server. This forces us to set up a local server on our machines. Usually this is a pain to set up, and setting up a server varies from language to language. Luckily, we won't have to mess with a single line of code related to web servers. The editor I recommend will automatically set up a server for you without having to touch a single line of code. This is great because we'll then be able to focus more on our code rather than the server code. Let's explore how that's done. If you don't have WebStorm, then that's fine. I'll provide an alternative in just a moment. Just keep watching. I'm going to start up WebStorm. Right now I have my HTML file opened up. On the menu above, I'm going to click on View. This will present us with an option to open in browser. You'll then see a list of browsers you can use. For this course, I'll be using Chrome, so I'm going to select this option, and then WebStorm will open up this file in the browser. This may take a while for some of you since WebStorm boots up a server. Like before, we have the text hello being displayed to us. However, what's different is the URL. Taking a closer look, you'll see that WebStorm opened this from something called localhost. Localhost refers to your computer. It's telling your browser that this file that just opened up is coming from your computer and not some external server. Just like that, without having to write a single line of code, you now have a server. There's a lot more going on behind the scenes, but that doesn't matter. We only care about what's being displayed on the browser and that our code works. We'll leave the server stuff to the server guys. Something I want to highlight is that this will only work for HTML documents. Let me show you what I mean. I'm going to go back to my editor and I'm going to create a new file called test.js. You don't have to follow along as this is just an example. With this file opened up and appearing inside the main active editor, I'm going to select the view menu item again. You'll notice that the open in browser option is gone. This is because WebStorm is unable to generate a server for a JavaScript file. If you don't see the open in browser option, then chances are you don't have the HTML document opened up in the main active editor. This does happen from time to time, so it's good to know. Alright, so that's how you boot up a server from WebStorm. If you can't afford WebStorm, then that's perfectly fine. There's another alternative solution that doesn't require you to write a single line of code. In the resource section of this lecture, I provide a link to a program called XAMPP. XAMPP is a program that allows you to create a server on a machine for free. It comes bundled with various programs that also help with web development. However, you don't need to be an expert in those technologies or even know how to use them. You can safely ignore those technologies. If you look right below, you'll see all the installers available. Download the one appropriate for your system and install it. Just go through the default installation settings. It's a normal program. Like anything else, you just click next and continue until it's finished installing. I won't be going through the installation since I already have it installed. Once you've installed it, you can open up a program called XAMPP Control Panel. It should look something like this. There are quite a few programs here, but the only one you need to use is called Apache. Apache will create and configure a server for you automatically. All you have to do is press start and it should boot up. You may get a message saying that this program requires permission to boot up a server. Just say yes so XAMPP can do its thing. Apache should turn green, indicating that the program is now working. If you don't see it turn green, then chances are that it failed. In this case, you'll need to look at this log below to see the error. You'll need to message the Apache Friends site and provide them this log so they can assist you debugging the error. If your server is ready, then you can press this button called Admin that will open up a new tab in your browser. It'll open up that localhost you saw earlier. You may see a welcome message from XAMPP, which is fine. I currently don't because I deleted those files. The welcome message is something you can safely delete and ignore for this course. Let me show you how to do that. Go back to the XAMPP control panel and search for the button called Explorer. It should be this button on the side with this folder icon. Click on it. This will open up the File Explorer on your machine. There are a lot of folders here, but as usual you can safely ignore a lot of them. These files just help you create a server on your machine. The only folder we care about is the one called htdocs. htdocs is short for hypertext documents. I want you to go into this folder and you should see a couple of files. You may have different files than I do because I deleted those and created some new ones. I actually use XAMPP often for web development. Anyway, you can delete every single default file you see in this folder as you don't need them. They're usually just files to help you get started with XAMPP. I want you to grab that index file you unzipped earlier and place it inside this folder. I'm going to do that now. Alright, so I just placed the file inside this folder as you can see here. I'm going to refresh the localhost page again, and you should now see the documents appearing like so. Just like that, you have your very own server. You don't have to write a single line of server logic as it's taken care of for you by XAMPP. To reiterate, D3 is a client-side library, so you don't actually need a server. However, we'll be requesting data from external sources, which does require a server, or else the browser will throw an error. Anyway, now that you have a server, you can then edit the files in any editor you like. It is not required to use WebStorm. For this course, I'll be using WebStorm's built-in server because it's more convenient. If you're using XAMPP, then you'll need to place all your files inside this htdocs folder. I do recommend you organize your files inside folders as we'll be working with quite a few projects. Let me show you how to access files from different folders. It's quite simple. I'm going to create a folder named example, then I'm going to drag and drop the index.html file inside this folder. Once you have that set up, you can then go back to localhost and change the URL to localhost/example. You should still be able to see the message like before. Alright, that does it for now. I'll see you in the next lecture. Before we write a single line of code, I want to give you a general overview of what data visualization is and why it's important. This course focuses on the code only, but it's important to understand some of the fundamental concepts I'm about to present as it'll help you better approach your projects. So the question is, what is data visualization? Data visualization is the ability to convey a story or an idea as efficiently as possible. As the old saying goes, a picture is worth 1,000 words. It's so that the end user can better understand a situation or story. As a result, the data visualization should allow the user to make an informative decision or just learn something new. Data visualizations can also help us explore patterns. Looking at a spreadsheet or table of data makes it harder for users to visualize patterns. Without a proper visualization, we could end up missing small disruptions in our data, which is even worse. So data visualization is an absolute important part of data science. If we were to break down most visualizations, we would find that most visualizations are made up of shapes, colors, and size. With just these three building blocks, we give the user insight about the data they're viewing. It's important to note just how much of an impact a visualization can make. Hopefully, you're given a job to present data in an unbiased and non-leading way. It's our job to present the data that's easy to understand and not necessarily sway them one way or another. I'm starting to jump into a gray area, so I'll leave it at that. Let's move forward. So now that we understand what data visualization is and its benefits, let's explore what makes a good data visualization. Here are 5 tips for making a great visualization. First, before you write a single line of code, it's important to understand the context of the data visualization. You need to ask yourself the following questions. Who is the audience? What do they need to know? What do they need to do with the data? It's important you answer these questions before you start writing anything. Tip number 2 would be choosing an appropriate visualization. You can only choose a visual after you know who your audience is. In the resource section of this lecture, I provide a link to a blog post about how someone chose a visual for a certain project. Be sure you read this so you can better understand the process. The site VizWiz is also a great resource for learning data visualizations, and I highly recommend you check it out. Alright, let's move forward. The next tip for creating a good visualization is removing clutter or unnecessary information. When you receive data, there is a probability that the data may have information that's not important for visual display. This tends to be common in maps. You'll have data that contains the coordinates and names of the area you're drawing. Along with the data, you may have types which aren't supposed to be displayed visually. Later in this course, you'll understand what types are, but for now just understand there are some situations where certain data shouldn't be displayed. Anyway, sometimes you'll have data that's more important than others, so you may prioritize it visually and push other data to the side for the user to look at later. This leads me to tip number 4. Draw attention using shapes, size, and color. If you have something that the user should primarily focus on, then don't be afraid to make it larger or make that piece of data stand out. It's a very straightforward tip, but a lot of data visual designers really don't bother making their visuals more interesting. Tip number 5 is to make sure your data tells a story. This is something you'll learn through experience and by studying other data visualizations. Some of the greatest data visuals out there tell a story. In the resource section of this lecture, I provide a link to a blog post by Google about the importance of telling a story with data. At the very beginning, there's a quote here which really resonates with me and summarizes why telling a story is important. Most organizations recognize that being a successful data-driven company requires skilled developers and analysts. Fewer grasp how to use data to tell a meaningful story that resonates both intellectually and emotionally with an audience. Marketers are responsible for the story. As such, they're often the bridge between the data and those who need to learn something from it, or make decisions based on its analysis. As marketers, we can tailor the story to the audience and effectively use data visualization to complement our narrative. We know that data is powerful, but with a good story, it's unforgettable. Read the rest of this article and watch the video to help you better understand this tip. So we've gone over what data visualization is. Let's talk about how D3 plays into all of this. D3 stands for Data-Driven Documents. I would say that's a great description for what D3 does. D3 helps you close the gap between the data and the visualization. In order to create visualizations on the web, you need to be able to calculate a lot of things such as size, position, color, text, etc. This gets even harder when you bring interactivity to your graphs. D3 assists you by providing a set of functions for displaying your data onto the document. The documents being the web page the user views on their browser. D3 is very specific on how you should go about creating data visualizations. It's in the name. You basically have two main parts. You have the data itself, and then you have the document. The data is what drives the visualization. It should never be the other way around. Your visualization should represent the data no matter what it looks like or how it's structured. Your visualization should not determine if the data itself changes. For example, if you have extra space or room on your graph, then that shouldn't mean the visualization should add something to the data itself. Instead, the visual needs to be adjusted, not the data. Throughout this course, we'll tackle projects in a certain process. We start off with retrieving the data and preparing some settings. Then, we'll prepare any functions we'll need. Then, we begin drawing everything onto the page using the data and the functions. Lastly, we'll add any interactivity if there should be any. You'll get a lot of practice with this process, so don't worry if you don't fully understand. Before I finish this lecture, let's explore some examples of good and bad visualizations. Let's start with some bad ones. This first example is pretty straightforward. It's a pie chart that shows you how much gold is distributed among countries. As you can tell, it doesn't provide much information visually, which just makes it terrible. This next example has too much visual information. It really doesn't highlight what's important, and there's simply too much clutter. This is an example of too much clutter and possibly a wrong choice for a visual. Since there's so much data, the author should have picked a graph that handles this much data. This next example is an example of data that is accurately represented but is extremely misleading. And this graph is comparing two CPUs by measuring the FPS in a particular game. The difference is only one frame, but this makes it seem like one CPU is vastly superior to the other. If you're not tech savvy with this stuff, then I'll fill you in. One frame isn't actually that big of a difference. In some scenarios, for certain data, a one number difference can be huge. However, in this example, a single frame isn't a big deal. If the frame difference was in tens, then it would make sense, but this is simply misleading. Let's explore some examples of nicely designed graphs. In the resource section of this lecture, I provide a link to a blog post about the repetitiveness in pop lyrics. This post is just filled with great visualizations and examples. The color choice is great, and everything fits nicely. They even took the time to make the post interact with the graphs itself. Let's look at one more. In the resource section of this lecture, I provide a link to a post about the US workforce and what it looks like now. Another great post where as you scroll down, the visual changes. Even if you're not interested in the data itself, the visual is something worth looking at. It can show you what you can do with data visualizations and how you can tell incredible stories. Alright, that's it for now. That does it for this section. In the next few sections, we'll begin coding and learning about the wonderful world of D3. I hope to see you there. In this lecture, we're going to learn about something called SVG. SVG is short for Scalable Vector Graphics. D3 heavily relies on SVG to create the graphs and charts it generates. SVG has been around for a long time and they're quite powerful. SVG is a text-based image format. Whenever we think of images, we tend to think of a group of pixels on a screen all combined together to make up something we can visually recognize. You can use programs like Photoshop or Microsoft Paint to create images. The phones on cameras can take pictures, which we can upload onto the web as an image. Some of the most common formats for images is JPEG, PNG, and GIFs. Another format is SVG. However, SVGs aren't generated like traditional images. Rather than it being something that a program or device can generate, it's generated with code. Code that you can read or write. There are some programs out there that can generate SVG images, but we'll get to that soon enough. I want to take a step back for a moment and take a look at this phrase, Scalable Vector Graphics. This may seem like an odd name, but it's not once you understand what each word means. Let's start with vector first. A vector is an image generated through math equations and commands. Let's take a look at a vector and a regular image. Right now I have a program called Illustrator opened. You do not need to have Illustrator installed, as this is just an example. As you can see, I have these two circles. The one on the left is a vector, and the one on the right is a regular image. From this distance, they both look fairly normal. But let's see what happens when I begin to zoom in on both of these images. As I zoom in, you'll notice that the vector on the left still looks nice and crisp, but the image on the right is starting to look pixelated. Eventually we'll come to a point where the vector image just looks so much better than the regular image. It doesn't matter how far we zoom in or out, the vector will always look consistent and clean. The regular image will continue to look distorted and pixelated. This is because the vector is created using math to always look good. Let's take a look at another example. I'm going to zoom back out so we can see both images. If you've ever tried to resize an image, you should know that the result is never really that great unless the image is high quality and big. Even then, the results won't be that great. I'm going to resize the image on the right. I'm going to change its height and make it look like a squeezed circle. As you can see, the width of the edge of the circle loses its consistency. The sides on the left and right are nice and thick, but the top and bottom are thin. I'm going to do the same to the vector image. As I scale it down, the vector image will keep its width no matter what size I scale it to. This is what's called a scalable vector graphics. It's an image that's created using mathematics and commands. It can be scaled to be smaller or larger, and it will never become pixelated. The advantage to using SVG images is clear. Now you may be wondering, why don't all images just be SVG images? Well, that's a really good question, and the answer is quite simple. SVG images require a lot of resources. If you want to have an image that is extremely detailed, then you would require a lot of power to generate this image. Even trying to move it can be difficult. SVG images are perfect for basic shapes and graphics. It's primarily used for creating animations or web graphics. It's also great for comics and basically anything that isn't super detailed. Illustrator allows you to export any image you create as PNG, JPEG, GIF, and even an SVG image. I'll show you how to do that soon, but let's take a look at what's inside an SVG image. I told you earlier that SVG images can be created with code. In the next lecture, we'll see how to do just that. Before you move on to the next lecture, I want to make one important note. Since we'll be using D3, D3 will take care of doing the heavy lifting. SVG images can become really complex, really fast, especially when your data is complex and big. The purpose of the D3 library is to make things easier for you. You don't have to memorize every single element and attribute there is for SVG images. It's important that you understand what's going on and why certain things behave the way they do. Anyway, I'll see you in the next lecture. Creating SVG images is fairly easy. Right now I have a basic HTML document. You can just use the document I provided earlier and clear the JavaScript code. We won't be needing the JavaScript portion at the moment. By default, most browsers support SVG images fairly well, so you shouldn't have any problems when using SVG. Creating an SVG is as simple as creating the element SVG. This is the minimum requirement for creating an SVG image. The SVG element is the container for all your graphics. The browser will look at this and know that you want to create an inline SVG image. This element can have a lot of attributes, but let's keep things simple. I'm going to apply two attributes called width and height. As you may have expected, this will give the element more space on the page. It's always good practice to give your SVG images a set width and height. I'm going to set both of these to 500. I'm now going to go to View, Open in Browser, which will boot up the server and open up a new tab. After the page has been loaded, you'll see that nothing really appears. That's to be expected since we haven't really created anything besides setting the width and height of an image. I'm going to right-click and select Inspect Element. This will open up the developer tools and set the tab to Elements. We previously discussed what the console and source tabs are for, but now we'll be working with the Elements tab. The Elements tab allows you to view your HTML document in real time. This is different from viewing the page source. If you were to right-click on the page again and select View Page Source, you'll have a new tab opened up with the document being displayed as raw text. This is the document as it's being served by the server. However, once it's loaded by the browser, then it no longer updates. The Elements tab inside the Developer Tools allows you to view the document and any changes made to it. For example, you would be able to see when an element disappears or when a new one is added. One of the great things about this tab is that you can actually edit and modify elements as well. If I were to hover my mouse over these elements, you'll see on the left that certain areas are highlighted in blue. This is telling us how space is being taken up and where the element is being placed. If you look at the document closer, you'll see the SVG element here. After hovering my mouse over this element, you can see its spot on the page. From this tooltip here, we can see that the size for this element is 500 pixels by 500 pixels. This is exactly how we defined it earlier, which is great. Something I want to highlight is that SVG elements can behave like a regular HTML element. You can apply classes, IDs, and even bind JavaScript events to this element. This is one of the reasons why D3 uses SVG. Not only can they adapt to any size, but they can be easily modified to suit our needs. This will allow us to make our charts and graphs more interactive. Let me prove this to you. We'll keep things simple. I'm going to go back to my editor and I'm going to remove these width and height attributes. We're going to apply these changes through CSS. I'm going to apply the ID attribute and set it to CTR, which is short for container. Then, inside the head tags, I'm going to create some style tags. Usually I would load an external style sheet, but this is a very basic example, so I'm not too concerned on organization right now. I'm going to select the SVG element, which would be #CTR. We can now apply the normal width and height properties. They both should have 500 pixels as the value. Alright, I'm going to refresh the page one more time, and nothing should really change on the page. But if we look at the Elements tab, you should be able to select your SVG elements. To the far right, you'll actually see all the styles applied to an element. As you can see, the width and height were both set to 500 pixels. Throughout this course, we'll be using a combination of CSS, HTML, and JavaScript to create our graphs. Some people think they can just use one technology to achieve the results, but that sometimes makes things harder than they have to be. Get into the habit of using a combination of technologies to achieve your results. It really will make things easier for you. I also want to mention that sometimes you won't be able to use CSS to make changes to elements. There are some elements related to SVG that can't be modified through CSS. That's perfectly fine. In these cases, you can just use the HTML attributes. In the next lecture, we'll start actually creating some vectors. I'll see you there. In this section, we're going to start with the basics of D3. We're not going to create anything fantastic. Before we can create complex graphs and charts, we need to understand the core D3 API. So let's get some things set up. Right now, I'm inside a new directory. I want you to create a new folder and point your editor to that directory. If you're using XAMPP, make sure you create your directory inside the htdocs folder. You don't have to name it anything special, just keep it simple. I'll be using WebStorm Server for this. In the resource section of this lecture, I provide a zip file that contains some starter files. Drag and drop the contents of that zip file into your directory. What you'll end up having is two files. The index.html file just contains a basic HTML structure. There is one important thing I want to highlight about this file, and that's setting the character set to UTF-8. We'll be dealing with a lot of data and functionality, so this will ensure that the browser will understand the code D3 generates. Then there's the app.js file, which is just an empty JavaScript file. I call my file app.js, but you can name this whatever you want. Once again, just keep it simple. We'll be modifying these two files soon enough. Once you have the basic files and folders set up, let's actually add D3. In the resource section of this lecture, I provide a link to the GitHub repository for D3. If you're not familiar with GitHub, then that's fine. GitHub just provides a place for developers to host and share their code with other developers. There are a couple of ways to download and include D3 into your project. I find the easiest way is to just use the CDN they provide. There are two versions here, and they're the exact same thing except for one. The standard version includes the file as it has been written. The .min version, as you can see here, includes the same code as the standard version, except all the indentation and whitespace has been completely removed. This is useful for when you're releasing your work onto production. It allows for faster loading times on your web page. The only problem is that the file is hard to read when it comes to development. Generally, as a rule of thumb, you use the standard version when you're in development. This allows you to open up the file and easily read the code to better understand what's going on. Once you're finished writing your script, then you just change this to the .min version for production. Min is short for minified. Alright, so I'm just going to copy and paste this one line of code into my HTML file like so. For this course, we'll be using version 4.11. If you see a higher version, then feel free to use it. All code we write will be compatible with future versions as well. That's another great thing about D3. It's very easy to upgrade from version to version with minimal breaking changes. Before we continue on, I do want to highlight one thing. If you've ever used D3 in earlier versions, then you're probably used to including one library. Usually most libraries, you just include one file and you're set. However, recently D3 has split itself up into various files. If you were to go back to the GitHub repo and scroll up, you'll find a link to the user's profile, which is D3. Under this profile, you'll see all the libraries uploaded by them. In this case, all D3 related code is placed here. When D3 first started, it was a basic library to deal with creating SVG elements through JavaScript. As it grew, the file size became alarmingly large. The file size was simply too much just for including D3, especially if you only planned on using some of the basic graphs. The developer behind D3 decided to break D3 into various components with each feature into its own library. This is great because now you only have to include code that you plan on using. The file we've included includes everything out of the box. This will save us some time from having to include every single bit we need. The trade-off is that the page may load slower than normal. Throughout this course, I'll be sure to tell you what libraries we're using and where you can find them. For now, we'll be using everything. The last thing I want to do is just include my app.js file below the inclusion of the D3 script. Let's check if everything is working. I want you to boot up your server and then view this page. For me, it's as easy as going to View, Open in Browser. You should see an empty page. You should check the console tab of the developer tools to make sure you're not getting any errors. Alright, so we have everything we need. In the next lecture, we'll start coding everything. Data. When you hear that word, what do you think it means? It's a very broad term that can mean a lot of things. What exactly is data? In the programming and technology world, data is almost everything. Images, audio files, text, the browser you're using to watch this video is data. It's a bit hard to understand it like that, but that's what data generally is. Luckily, when it comes to D3, data is broken down to be more specific. Data to D3 is just text and numbers. Generally speaking, your data can come from 4 sources. You can hard-code it into your JavaScript file, which is what we'll be doing in the beginning. Then there's data that comes from external sources. You can place your data in text files, also known as TXT files. There's also JSON, which is a JavaScript object in its own file. Lastly, there's spreadsheets or CSV files, which is short for comma-separated values. All 3 of these file types can be used with D3 easily. Data really can't do anything by itself. When it comes to data visualization, there are 2 parts to it. There's the data itself, which can be text or number-based. For example, the amount of dog owners in certain cities or how many students hold a certain grade. All of this would be considered your data. Then there's the second part, which is the visual part. For this course, that would be HTML and CSS. The average user can't understand raw data or understand HTML and CSS. That's where the challenge comes in, combining these 2 parts together into something the user can understand. Hence the phrase, data visualization. D3 is the library that bridges that gap, and it makes it easier for you to combine the data and the visual part together. Right now, let's focus on learning how to make elements appear on the page. Later, we'll learn how to add data into the mix. Right now, I'm inside my editor, and I have both my index.html and app.js files opened up. To start things off, I'm going to add my code inside the JavaScript file. When you loaded D3 through the script tags, you are provided an object called D3. This object will contain all the properties and methods related to D3. Usually, the first thing you'll want to do is select an element. Doing that is very simple. The D3 object has a method called select. You simply pass in a CSS selector of the element you'd like to grab. For example, if you wanted to select an element with a certain ID, then you just pass in a hashtag followed by the ID name. So if I had a div tag with the ID of foo, then I would pass in hashtag foo. For classes, you would use a dot instead of a hashtag. Lastly, if you just wanted to select a plain HTML element, then you would just pass in the element's name. So if I wanted to select a paragraph, then I would pass in P. Basically anything you can select with CSS can be inputted here. This is one method of selecting an element. Another method is by using the select all method. This works the exact same way as the select method, except for one thing. The select method will grab the first element it finds. For example, if I passed in a paragraph tag, then this will select the first paragraph element it finds. Even if we had multiple paragraph elements on the page, this will still only grab the first one. If you wanted to grab all the paragraph tags on the page, then you should use the select all method, which does this. So we have two methods here for selecting an element, but I'm going to just stick with the select method for now. I'm also going to change this to select the body element. We don't have a paragraph tag, but we do have the body element, which will work for now. I'm going to create a variable named L, which is short for element, and assign it to this value. Right below this, I'm going to console.log the element. I want to see what exactly is going on internally. I'm going to boot up my server by going to View, Open in Browser. Nothing is going on in the browser, which is to be expected, so let's check out the console. Inside the console, we have an object being logged, which is called selection. A selection is a JavaScript object that represents an HTML element on the browser. This is very important to understand, as selections are the most common objects you'll be working with. Essentially, when you're working with SVG elements, they are referenced as a selection object. In the resource section of this lecture, I provide a link to the D3 selection repository. This basically documents and contains all the code for the D3 selection library. As I stated earlier, D3 has separated itself into various libraries for optimal performance. The developer behind D3 has gathered a lot of data and has determined that the selection library is commonly used, so he decided that it should be part of the core by default. You don't have to include this, as it's already part of the core. However, if for whatever reason you just want to use the selection library by itself, then you can just download it here. So basically, the selection library is a way to select and change HTML elements. It's a very basic library. Feel free to read up on this page to learn more about it. We will discuss many of its features throughout the course. You will definitely get a lot of practice with it. Anyway, let's go back to the page and view the console tab again. Inside this, you'll see that the selection object contains two properties called groups and parents. We won't be diving too much into these two, as it's not required to know. This is really for D3 in the browser to understand and use. Generally, the parents property contains the element that the element we're currently selecting is contained in. The groups property contains an array of the elements we selected. Let's look inside the groups property. Since we're using the select method, you will usually only see one element in the array, which is fine by us. Eventually, after going deep enough, you'll find the element with all the data applied to it. There's a lot going on here. All we did was write one line of code, and all of this was created for us. For the most part, we don't have to worry about a lot of this, as it's handled for us by D3. What I do want to highlight about this data is the element itself right here. The body tag is represented here for us. This is not a string. This is the actual element itself. If I were to hover my mouse over this element, then you'll see my browser at the top highlighted for us. It'll be represented by this orange-red rectangle of the page itself. I can even click on this, and I'll be taken to the Elements tab of the Developer Tools. The Developer Tools will automatically select the element we're selecting in JavaScript. This is one way to verify what elements you're currently using. So basically, D3 has given us a way to reference the actual element on the page. If you've ever used jQuery, then this concept should be familiar to you. Let's take a look at what a list of elements looks like. Back inside my file, I'm going to change the select method to select all and change body to P. We don't have any paragraph tags inside the HTML document, so this should return nothing. Once you have this changed, go to the HTML file and add a couple of paragraph tags. I'm going to add 3. With that all set up, let's refresh the page and check out the console. As usual, we have the selection object being displayed, and we have the groups array populated with all our elements. I added 3 paragraph tags, so I'll see 3 paragraphs being selected. One difference you may notice is that D3 will refer to this as a node list. You'll hear the word node a lot in tutorials and even in your code. Basically, a node is the technical term for anything and everything in your document. That seems strange to hear, but that's what it is. Your elements are nodes. The attributes inside them are nodes. Even the text inside your elements are nodes. So when you see the word node list, it's basically saying a list of HTML elements. For the most part, you don't have to worry about the technical words here, as it's just for D3 and the browser, so don't worry about it if you don't fully understand. Alright, I'm going to remove these paragraph tags and change my code back to its original state. I don't plan on using these at all. I want to keep everything simple for now. The last thing I want to show you is how to add elements. Usually when you select an element, you want to add onto it. Adding another element is very simple. Right after selecting the element, you can use the append method. This method is also a part of the D3 selection library. Even though the select method returns the selection, we still have access to the D3 library itself. This is taken care of for you. It's the magic behind the D3 library. This method accepts the name of the element you'd like to create. I'm going to keep it simple and pass in a paragraph tag. Let's refresh the page and see what we get. If you were to view the Elements tab, then you should see the p tags inside the body tag. So basically the append is doing 2 things. It's creating the element, and then it's adding onto the current selection. In this case, it would be the body tag. It's important to note that the element will be added inside the selection at the very end. This is why the paragraph tag appears right below the script tags. Let's view the object now. You'll notice that the selection changes to the p tag rather than the body tag. This is to be expected. D3 will shift its focus to the element you just added when you use the append method. Behind the scenes, D3 will call the select method for you and pass in the element you just created. By doing this, you are no longer manipulating or using the body element anymore. It's very important you understand this. Back inside my code, you'll see that I'm chaining all this together. The idea of calling one method after the other is called chaining methods. This is something that D3 heavily adopts. If you were to view any examples from D3, then you'll see there's a lot of chaining. This is something I want you to get used to. We'll be using a lot of chaining methods. In most cases, a lot of methods return the selection you have. If you don't understand or don't know what a method returns, then it's always a good idea to log the data or just check out the documentation. D3 is really well documented and will usually tell you what you can expect after calling a certain method. Of course, you can break this chaining method by using variables. Let's say I wanted to have a variable for both the body tag and paragraph tag. Well, that's simple to do. Right after selecting the body tag, I'm going to add a semicolon. Then I'm going to create a new variable named p and set its value to l.append, like so. Writing it like this is the same way we had before. The only difference is that now we have 2 selections being stored. If you wanted to continue adding onto the body element, then you can just reference it using the L element like we do in the second line. If you wanted to add more stuff to the paragraph element, then you can just reference it using the p variable. As the course progresses, you'll see me chaining methods and sometimes breaking that chain. You can use either style, but I usually like to mix them both together for readability and reusability. It's all preference. I'm going to undo these changes and just go back to what we had before. There's no need to break down our code like this right now. Anyway, that does it for now. There's actually a whole lot more things you can do with selections, but we'll explore that as the course progresses. I'll see you in the next lecture. In the previous lecture, we took a look at selections and how to create elements. At this point, you should have a basic understanding of the selection library. Now we'll take a look at how to manipulate those selections. Right now, I'm looking at the D3 selection page. If you scroll down a bit further, you'll come across the API reference section. We've already gone over selecting elements, so now we'll be taking a look at modifying elements. Here is what D3 has to say about these methods. After selecting elements, use the selections transformation methods to affect document content. So basically, these set of functions will allow you to add and remove attributes. You can also change the content inside elements that you have selected. It's important that you have a selection before you apply these methods. I'll talk more about that later in this lecture. Let's get started. The first thing I want to do is add some attributes. To do that, we need to call the attributes method. I'm chaining this right after appending the paragraph tag. In this case, the attribute will be applied to the paragraph tag since that is the current selection. If I wanted this to be applied to the body tag, then I need to call this method right after selecting the body tag. For now, I want to apply this attribute to the paragraph tag. This method has two parameters, which is the name of the attribute you'd like to add and the value. One of the most common attributes you'll find yourself adding is the class attribute, so let's pass that in as the first value. The second parameter for this method is optional, but usually you'll set it anyway. This will be the value for this class. I'm going to apply the foo class. We haven't defined this class, but that's okay for now. This is just an example. Just for fun, let's use another function. Right after this, I'm going to chain another method called text. As the name describes, this will add text inside the current selection. I'm going to set this to Hello World. I promise I'll break down a lot of this, but let's check to see if it's working first. Boot up your server and navigate to this page. We should see the paragraph tag being displayed with the text inside. If you were to view this inside the developer tools, then you should see the class foo being applied to this element. This is exactly what we wanted. So now that we have that working, let me break down what's going on. Back inside the editor, I want to format my code a bit. When it comes to D3, you'll be doing a lot of chaining. When you're chaining 2 or 3 methods, it doesn't really look that bad, but we're going beyond that here. Having your code all in one line just makes it really hard to read, so I'm just going to indent everything. This right here is preference and what works for you. In a lot of examples, you'll usually see code formatted like this, so it's good practice for you to get into the habit of it too. With that formatted, let's explore these two methods I just introduced. D3 refers to these methods as transformation methods. While they are provided inside the selection library, they do have a couple of differences from the methods we used in the previous lecture. As the name suggests, these will change how an element appears or works internally. With that being said, they will only work if you apply them to a selection you made previously. The order of methods matter a lot here. If I were to directly call this method at the very start of the chain, then this will simply not work. Another thing you should know is that transformation methods will return the selection it's being applied to. These methods will not create a new element, nor will they select a brand new element. This is why I can call the text method right afterwards. This attribute method will add the class foo to the paragraph tag, and then it will return the paragraph selection to be used by the next method. In this example, this would be the text method. And of course, the text method will return the same paragraph selection. In my code, you can see that I'm still logging the element into the console. Let's go back to the browser and see what selection is returned. As expected, we should see the paragraph tag being selected. You'll see that the class foo is being appended to the name. This is great because we have a real-time representation of the element in JavaScript. If you're adding an attribute that isn't a class or ID, then you most likely won't see it like this. There are two ways to check if an attribute is added. You can go to the Elements tab and check the element yourself. Here I see the class is definitely being applied. Alternatively, you can check the console and look into the object deeply. Inside this object, I can see we have a property named attributes. This is where all the HTML attributes are stored. Eventually, after digging through a little bit, I'll find the class attribute and its value foo. I know I've said it a few times, but I'll say it again. It's not important that you understand what's inside these objects. A lot of this is for D3 to use. Usually I don't find myself looking into these objects since everything is generated in HTML form. When I do look into these objects, it's because I'm desperate and I don't understand what's going on. In these cases, I try to understand the JavaScript object D3 provides so I can debug my code properly. The attribute property is the one I find myself checking the most. Alright, now that we understand that, let's go back to our script. So one thing I want to mention is that the attribute method will override an attribute even if it exists. For example, right now I'm adding the class foo, but let's say later in my program I wanted to add another class. Well, let's see what happens when I call the attribute method with the values of class and bar. This should add the class bar to the element. After making these changes, let's refresh the page and inspect the element. As you can see here, the class foo is completely gone. This is because the attribute method removed the original value and replaced it with the new value. There are two solutions here. We could update the attribute method to contain both classes, but this isn't practical. This is because data can be dynamic. If we needed to apply classes after a while, then trying to rewrite the attributes can become hard to manage. Luckily, D3 provides an alternative method for this. I'm going to comment out both these method calls. Then I'm going to call a method called class. This is a special method meant specifically for adding and removing classes from an element. You simply pass in the class name and then whether it should be added or removed. The class I want to add is foo. To specify if it'll be added or removed, then you just pass in true or false respectively. I want this to be added, so I'll set this to true. If this class already exists, then nothing happens. I'm going to call this method again, except this time I'm going to pass in bar and also set this to true. The great thing about this method is that it won't completely overwrite the attributes. Let's refresh the page and see what we get. As expected, we'll now see both classes being applied. There's one last thing I want to show you, and that is adding inline CSS. It's very simple and you may have an idea of how it would look like. At the very end of this chain, I'm going to call the style method. This will accept the name of the CSS property and its value. I'll keep it simple and set the color property to blue. Refresh the page after making these changes. The text has now turned blue. So that's how you would manipulate selections. There's actually more things you can do, but we'll learn more about those as the course progresses. One of the most important things you should understand is whether or not a certain method will return a new selection or return the one it's being applied to. It's always a good idea to check out the documentation to confirm just in case you forget.